All right, ladies and gents, number 26, very straightforward. Okay, just make sure you look what they're asking for. It says you have a wave and you're looking for amplitude. Amplitude is the distance from the middle to the top, and that amplitude goes up to 4. And I don't know why we're getting little boxes appearing here, but that is 4 centimeters. So let's rock a little amplitude of 4 centimeters. Number 27, we're looking at the period of a water wave. We got 4 waves in 10 seconds. All right, remember, period is the number of seconds per wave. So if we have 10 seconds, it gives us 4 waves. We want to find out the number of seconds for 1 wave. So you can just do a little cross multiply. You end up dividing 10 by 4, and you get 2.5 seconds after you solve that out. Next question, you are being asked to find the point that is 90 degrees out of phase with point P. All right, so if you have the point that's from here to here, all right, 1 full wavelength, remember, is 360 degrees. All right, so if the full thing is 360, that means half is going to be 180, and then halfway in between that is going to be 90. And if we needed to find 270 would be here. And so boom, 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 boom. That is point B, 90 degrees. Next one, again, very easy if you know that you have some information from the front of your reference table. It's asking us to find wavelength, and it's giving us frequency, and it's telling us we have a sound wave in air at STP. All right, all this little thing right here, sound wave in air at STP, that should be sending off alarm bells for you, right? Because you know something about these sound waves. You know that you have the velocity is 331 meters per second. So you set up a little wave velocity equation here, and you plug in your numbers. Equals 256 hertz. Uh-oh. 256 hertz right here. Times our unknown wavelength. Just divide both sides by 256. That cancels out. And 331 over 256. Wavelength equals 1.29 meters. Number 30, this is asking to find energy when you have an electron and electron antiparticle called a positron annihilating each other. Right? When you have annihilation, annihilation is a mass energy conversion. So if we need to do mass energy conversions, we need to bust out our mass energy conversion formula. All right, we got 2 of these. E equals mc squared, and we also have 1u equals 931 MeV. Now, if you look at this, okay, we're giving energy. Energy is in joules. And that is frustrating with this annoying pen here. As I was saying, we have 2 ways to convert mass into energy. We have E equals mc squared. We also have 1 universal mass unit equals 931 mega electron volts. Right? The units here, we need to use joules for energy and kilograms for mass, whereas over here we're using universal mass units for mass and mega electron volts for energy. Our problem here, all of our energies are in joules, so we should definitely use this E equals mc squared formula and do not use this. All right? So what we're missing is we don't have the masses. We don't have mass yet, but we do know that we have an electron and an antiparticle electron. And if you look on the front of your reference table, you know that mass electron equals 9.11 times 10 to the negative 31st kilograms. Right? We also know that the mass of a particle and its antiparticle are the same. All right, so we are going to do E equals mc squared, and we are going to plug in our 9.11 times 10 to the negative 31st kilograms for our electron, and put our speed of light. All right, and I'm not sure what this gets. Oh, I think this is roughly 8 times 10 to the negative 14th. Negative 14th. All right, but the trick here is you have two particles. Right? Each particle has the same mass. So you have this times 2. You have this energy first for the electron with this mass, and then you have this again for the antiparticle electron that has the same mass. So two particles. So take this, multiply it by 2. Your final answer is about 1.6 times 10 to the negative 13th joules, corresponding very nicely with answer choice number 1.